This next problem is classified as a combustion analysis problem. And so what we have here is we have a hydrocarbon that we're trying to find the empirical formula of, and it's combusting. So that means it's reacting with excess oxygen to produce carbon dioxide gas and vapor. And according to the problem, we have 3.750 grams of our hydrocarbon, 10.05 grams of carbon dioxide, and 2.470 grams of our water. So we need to find out the amount of carbon and hydrogen. And so we're going to get our amount of carbon and hydrogen from the amount of carbon dioxide produced and the amount of water produced. We have our first step, which is to determine the amount of carbon. We have 10.05 grams of carbon dioxide. And we're going to divide by the molar mass, which is 44.01 grams per 1 mole. We know according to the chemical formula of carbon dioxide, there is 1 mole of carbon dioxide for every 1 mole of carbon. So this gives us 0.2284 moles of carbon. Okay, so we're going to keep those moles in mind, but we also want to determine the amount of grams, and we'll see that purpose later on. We're going to multiply that by the following conversion. For every 1 mole of carbon, we have 12.01 grams of carbon. So that's going to give us 2.743 grams of carbon that we have. Now our next step is we're going to determine the amount of hydrogen. We have 2.470 grams of water. We want to convert this to moles. So we know that there's 18.02 grams of water per 1 mole of water. And now, according to the chemical formula of water, 1 mole of water contains 2 moles of hydrogen. If we multiply that on our calculator, that ends up with 0.2743 moles of hydrogen. And if we multiply by the molar mass of hydrogen, so 1 mole of hydrogen is for every 1.008 grams of hydrogen. And that ends up being 0.2765 grams of hydrogen. Now we can determine the amount of oxygen if we take our total amount of sample minus the grams of carbon minus the grams of hydrogen and so that will equal the amount of oxygen that we have, which is 0.7305 grams of oxygen. and we can convert those grams of oxygen to moles. Which is our fourth step, 0.7305 grams of oxygen that we're going to convert to moles. And that ends up with 0.04566 moles of O. And then what we're going to do next is divide by the lowest number of moles. So we have carbon, we have 0.2284 moles. For hydrogen, we have 0.2743 moles. And for oxygen, we have 0.04566 moles. And we're going to divide by the smallest number of moles, which is 0.04566. So we end up with C5H6O, and that's going to be our empirical formula for clove oil.